All right, so we saw yesterday when we made the chart that there are all sorts of images you can get from different situations. We can use ray diagrams to predict when and where we're going to find images. So what you do is you start by doing this. You just draw what we call a nice straight line, which we call the principal axis. It's sort of like the center of the lens. And you put the lens somewhere in the middle-ish. And you really just draw a straight line. In your mind, you're like, here's the lens like this. We'll draw a convex lens right now, a converging lens. Since we show where the light doesn't really bend when we show it in the middle, straight line is your best bet. We know there are two focal points, one on each side of the lens. All right, we're guesstimating at this point where they are. And we'll have an object over here. So we already know some things about rays. We know that if a light ray comes in straight towards the lens, and we call that parallel to the axis, like this, it hits the center of the lens, and really it bends here and it bends here, but we pretend and show it here, and it comes out through the focal point. That's how we define the focal point. So sort of makes sense that the opposite statement would be true. If it comes through the focal point on this side, it really bends on the way in through the lens and the way out of the lens. We show it at the center spot. It will bend and come out what we call parallel. Where these rays meet, that's where we see the image. And since this came off the top of the lens, the top of the object, this is the image right here. It's upside down, which tells us this is a real image. And we can see from the picture that they're about the same size, although maybe this one looks a little bit smaller, but it's certainly much closer to the lens than this distance here. This is what we would call the object distance, and this is what we call the image distance. Now, there's one more ray that I didn't draw in that picture that you can draw. There's our principal axis. Here's our quote lens, and we'll say it's convex. There are three rays we know about. Sometimes some are more easier than the others, so you pick and choose. One is, if it comes in parallel, it bends and comes out through the focal point. The other is the one we saw on the last problem. If it comes in through the focal point, it bends and goes out parallel. And the third is, there is one ray that if it hits smack dab in what we'd call the center of the lens, it doesn't bend at all, which is a lie. It bends on the way in, it bends on the way out, it just undoes itself. So we draw it straight through, and voila, here's our image. If we draw the third ray, which is extra bonus at this point, it would come in through the focal point, and it'd come out parallel, and voila, they all meet at the exact same spot, because that's the only spot you can find an image at.